Welcome to Next BCB. Today we are going to disassemble and analyze the handle of Quest. First, let's look at the appearance. It's black overall. We see a logo here. It's carved into molds and then poured. Then a softer material was used on the back. We determined that it used a secondary injection molding process. The overall appearance is black. The surface has a large area of matte finish. The two buttons here are made of high-gloss material. Here are some clamping lines. Some of the more obvious clamping lines. These are clamping lines. So what we do is we take it apart. We start by removing the battery. The design of the battery compartment is very clever. It uses two magnets to install. No buckle is used. Insert magnets directly into plastic parts. Remove the battery. Still no screw holes found. But there's a hidden label. The screws are usually hidden under the label, or hide it under something else, like a non-slip pad. Let's peel the label off. There is a layer of film on the surface of the label to protect the text from wear and tear. Remove the label and we see that there are two screws underneath. Next, unscrew the screws. Two self-tapping screws. Next, we pry open this part. I found that the button is assembled independently on the part. This entire structure. There are some tendons on the outer wall. These positions are tendons, used as a buckle. We now see two crossed widgets inside the button. This part is soft and may be made of silicone rubber. Also, we found a metal here. Let's test it out. This is a magnet. So somewhere around here, there's a hole sensor. It measures how much a button has been pressed. Let's unscrew the screws first. Remove the battery base. OK. Finally opened. The whole part is circular. The internal structure is a semi-open ring that expands outward. When it is fitted into the structure, expanding outward forms a self-locking buckle. When I cut it, I found that it is made of this vitreous body. The material of this part may be PS. The color of the parts is also transparent. We see that it's transparent. It gives off some gray color. It can be judged that it has probably been sprayed with a layer of paint on the outer wall. This ring is very challenging for mold processing, especially when the mold is demolded. It's got an inverted button inside. There are also inverted buckles here. These two are also upside down, so the mold can only shrink and fall off to the inside. Shrinking inward and falling off is a very complicated process, so the mold cost for this part is very high. See, this ring is not pure black, but translucent. These are the components that send and receive infrared rays. So it has to be translucent to match the infrared band. There's a circle of sensors on this part. The FPC is also fixed on this by hot mount. And the button is fixed to the structure by a shaft and a spring. In addition, we can also see here's a silicone pad. Let's guess what it does. Yes, it should be impact prevention. There is a separate screw on this part. What is this screw for? This is a button made up of two parts. The top half is made of plastic with a metal sheet. Lower half. It's a hidden magnet. It may be the same principle as the button just now. Hall sensors are formed by magnets. There's a silicone plug. The end of the plug should be a magnet. Magnet. Silicone plug. It's used to attach to structures. The advantage of using silicone plugs is that they can tolerate greater tolerances. It can press the magnet very tightly. It can also be assembled on the structural part while being pressed. This whole joystick is a module. It should be easy to unplug. Just unplug it. A spring is assembled inside. Check out this part. The top half of this part is made of rubber material. And then at the bottom is plastic. This part should also be made by secondary injection molding or gluing. So why was it challenging to build this part? Because the whole ring is an inward concave complexity. The inner wall forms an arc. So it's an inverted mold opening. At the same time, we need to maintain the elasticity of outward expansion. Then its thickness cannot exceed the original standard. In addition, making rings is difficult. It also has a base. It has an upward slant. At least in this position, it's clearly sloping up. Or you need a mold with the upper and lower halves separated. We see a more obvious clamping line. So this mold is split in half on the left and right. And this part is independent. Clamping line will twirl inside. So the mold contracts inward and then recedes. This part is a bit heavy. Look at the outer layer. Same as this joystick. They are all made of non-slip rubber. Well, this is the whole process of dismantling TUUEST. Welcome to follow our channel.